All right, good morning, everyone. Welcome to the second day of Google I/O. I hope you had a great first day, and you're clearly the most engaged crowd because you made it to the morning session, so good job on that. My name is Florian. I'm the product manager for the Places API, and here on stage with me is Ravi.
Good morning.
He's the engineering lead for the Android Places API. And we would like to talk to you this morning about how you can understand your place in this world. And one of the things I really like about Google I/O is that it brings together people from all over the world, right? So I flew in from Australia, and I'm pretty sure a lot of you have also spent quite a bit of time on an airplane. And sometimes when I'm on an airplane, and when you fly from Australia, you always have a lot of time on your hands, then you kind of relax and you sit back and you look out the window, and sometimes it hits you a little bit that you say, wow, the world is really, really huge, right? And we inhabit such a vast space. And humans have always tried to structure and understand the place and the world around them. And there's many different ways how you can do that. And if you look at this medieval map here, for example, this is one way how you can structure the world, right? So you see the globe, and by the way, that was an important insight that we in fact live on a globe. It took humans a couple of iterations to get there. Once you have that, then you say, okay, let's put a coordinate system on that. And these coordinates are called latitudes and longitudes. And a set of latitude and longitude can describe a unique place in the world. And that's one way how you can describe it. And that's really useful if you're navigating the oceans or if you are a geographer. But it's not very humanly feasible. It's not very useful in our daily lives. I don't think in latitudes and longitudes. Another way how you can structure the world around you is by saying, okay, let's use street addresses, right? It works in most countries quite similar, that you say you have some system of a postcode, a city, street address, and a house number, and all these things together lead to a building. And if you're getting your parcel delivered, that's really useful. But then again, it's not the most intuitive thing. I maybe remember my personal home address. On a good day, I remember my office address, but not much more, really. So there must be different ways how we perceive the world around us, how we memorize things around us that we care about. And that is really much more of a semantic notion. It's more about semantic places. And what I mean with semantic is that we are much more visual, right? When we look around ourselves, like here in Piccadilly Circus in London, you see billboards, you see storefronts, signs, colorful things, you see a bus at a bus shelter, you see a historic facade of a beautiful old building. All these things, that's what sticks in our minds. So we remember places by their names and by their attributes and their characteristics. And understanding the world in this way is very much related to the core of what Google does. Because people search for a lot of things, and they search for physical places in the world out there. And they want to understand these things when you search for shoreline amphitheater, for example. So understanding the world in this way is quite challenging because, first of all, there's a lot of these places out there. There's hundreds of millions of places. And all of these places, they change all the time. So we estimate that roughly 10 to 20% of places every year shut down and open up again. So you need to be constantly updating all that. And the third aspect that makes it quite tricky is that these places have different types, right? And you care about a different type of a place, you care about different attributes. You care about an ATM in a different way than you think about a hospital or a cafe. So all of these things contribute to the fact that, well, doing places is really, really hard. And Google has its very own unique approach in order to get this problem right. So what we do is we ingest a lot of different data sources and bring them all together into one big representation of what the places in the world look like. And I'd like to walk you just through a few of these. One of the data sources we use for places is Street View. And as you can see by the number of vehicles that we drive around the world and the kind of vehicles that you see there, we don't just stop at the public road, but we go a little bit beyond that. And that's a tremendous effort in order to understand what does the world look like from a street level perspective when you walk through a street and you look at the storefronts and everything like that. Another information source that we use is satellite imagery. So satellite imagery tells us about the places and their building outlines. It tells us about how these buildings are located relative to streets and other points of interest. And as you can see from this example here, we use satellite imagery also for other interesting projects, like Project Sunroof, which tells house owners how to calculate the solar capacity of their building and how much money they can save by putting solar panels on their roof. Another source of information are the users themselves, right? So we have so many people out there using Google Maps, and they all can tell us if they think something is wrong or something needs to be updated. And they say, hey, this place has changed its location, or it has changed the name, or the opening hours are not right, or maybe it has shut down. So we get a constant stream of suggestions from our users about what needs to be updated. And last but not least, another important source of information for us are the business owners themselves. If you own a business, you really care about the fact that you're being found if somebody searches for you on Google. So as a business owner, you can sign up to Google My Business. And when you have this account, you can claim a place. And you can say, this is my place, this is my store. And you can make sure that all this information in there is right, that it has the right name, the right opening hours, it's in the right place on the map. So these are just a few examples of information that flows into places at Google. And I'd like to stress the fact that this is a real unique thing. This is a differentiator if you compare us to many other information sources that you can have for places information. This is really hard to do. This is a lot of sweat and labor that goes into maintaining this type of database and keeping it up to date. And so we share this information with the consumers through Google Maps and with developers through the Places API. And what I'd like to do now is to just walk you through the main kind of questions and problems that you can solve when you use the Places API. The first kind of question that you can work with is to answer this simple sounding question of where am I? What's around me? Where am I right now? And the traditional way how you deal with that is that you use geocoding, right? So you have, for example, a latitude and a longitude, and you convert that with geocoding into a street address. Or you go the other way around. And that's perfectly fine for what it does. But it doesn't really tell you about the semantic layer on top that I just talked about. The street level or the address, it doesn't tell you what kind of place you're going to find there, what characteristics it has. In order to address this additional layer on top, you need some kind of a descriptor and an identifier for that. And we use the place ID for that. So the place ID is this unique identifier that gives you access to all these kind of semantic places. And it has a pretty broad scope, so it pretty much covers most things that you as a developer would care about on a Google map. We use place IDs to describe establishments, such as restaurants and cafes, points of interest, such as a beach or a park, or also geopolitical entities, such as a city or a state or something like that. And there's also a whole bunch of other places that we describe with place IDs, such as road segments, addresses, like your personal home address, or also intersections. What I'd like you to keep in mind about the place ID is that it is a unique identifier, so no two places have the same place ID, that it is stable over time, which means that you can store it indefinitely for your purposes, and that it is global. So that means, as far as Google's geodata goes, we use the place ID all around the world. And now that we have a place ID, we can come back to answering this question about where am I right now? So the Places API has a function that's called getCurrentPlace. And getCurrentPlace will give you a list of places. And each one of these places is identified by the place ID, and it comes with a likelihood attached to it. And this likelihood expresses the confidence that Google has in that a user is at a certain place at a certain time. And I want you to keep this likelihood here in mind for a little bit later when Ravi speaks, because he's going to go into much more detail and explain to you what this likelihood really means. It's quite interesting. Another way how you can tell where you are at the moment is, well, just ask your user, but ask them in a nice and friendly way. So what we offer for that is called a place picker. So this is a visual experience that allows the user to drag and drop a pin on a map. And once you've done that, then it shows you a list of the nearby places. That is really, really convenient. For example, if you want to build user location sharing into your app, and you want to get the same experience that you get, for example, right now on Google Hangouts when you tap Share My Location. Another kind of key question that you may ask is, well, okay, now I've retrieved the place, so what's at this place? Tell me more information about this place. And what we give you for that is something called a place details request. Place details gives you a lot of information about the semantic nature of a place. It gives you, just like geocoding, the street address and the latitude and longitude, but much more than that. It gives you the name, which is how most people identify places. It gives you a place type, and the place type is really, really actionable. Think about it, if you're building an app that has a number of notifications in them, the notification behavior of your app may be completely different if you're in a quiet place, like a hospital or a library, as opposed to you're in a busy commercial place, like a mall. It also has contact details that makes your app much more actionable, right? So if you're adding to the description of where a user right now is, if you're adding the website or the phone number, then they can just call up and make a reservation, for example. It has store opening hours in there, which is really, really important for many users, because in many use cases, you only care about places when they're actually open. Otherwise, who cares? And it has reviews and ratings. That is really, really important if you're trying to make a choice about, do you want to go somewhere? Many people really rely on these ratings and say, I never go to a place that has less than a 4-star rating. The second piece of information that we give you are photos. We have millions of photos in the Places API, and we make them all available to you. So you can build a really visually rich experience for your users. And again, it helps the user more to understand what a place is about if you're adding more photos to your application. If you're looking at a restaurant, seeing more photos of the place, seeing what it looks like from the inside, from the outside, what a menu looks like, does the food look good, all of these things help you understand what is this place about and do I care about this place. Which brings me to my third point, how you can discover places around you. So tell me more about interesting places around me. One way of doing so is using autocomplete. This is a really, really popular feature that a lot of apps use these days in order to help the user discover places. If your user knows the name of a place or they know a part of the street address, they can just start typing. And as they type, autocomplete gives them an interactive experience where you just, as you type, get suggestions of places that look like what you've just typed. And then you just select it from a drop-down box. So for example, if you're building a ride-sharing app and the user wants to enter the destination of where they want to go to, autocomplete is a great way of doing that. And the other way how you can discover a place is through search. Search is a really, really interesting one because a good search result means something very different to everybody depending on what use case you have. And if you think about the factors that go into what means a good search result to you, it could be many different things, right? So you search for a particular string, and of course a good search result is a result that matches your search string in a very good way, but there's other factors as well. Proximities are an important factor in order to determine, okay, so there's a place that has a name that looks similar to what I've searched, but is it close to the area where I wanted to get it from? Another factor is the prominence of a place. You may want to rank places higher that have a high prominence. With prominence, I mean, are they popular? Are many people going there? Does it have positive reviews? That kind of thing. And the last point is that you may have a personal bias in the way how you want to see places. You may care about certain characteristics of a place much more than others do, and therefore you want certain places to be ranked up higher. So let me walk you through a couple of examples to illustrate what I mean by all of that. Let's start with a very simple example. Let's say you search for Sydney Opera. Sydney Opera is a fairly specific string, and if you search for that, the only matching place for that is the Sydney Opera House. So you just get one result, and that's what you see as a red dot here on the map. That's very simple, and very feasible. Let's make it a bit more complex. Let's say you search much more generic. You search for cafe in Sydney. In this case, what happens is cafe is a very broad term, so you have a lot of places matching this kind of search string. And Sydney is a very broad term as well, because the city of Sydney is pretty large. So you get a lot of matching places. So what the Places API here does is it gives you a set of search results, and you see here the top 20 results, and they are ranked by both prominence and proximity. So it will select places that have both a high prominence, they're really popular, and they are fairly centrally located within Sydney. Now, let's make this search a little bit more specific. Let's say you care about expensive cafes in Sydney. If you do that, you're going to see that the search result set looks completely differently. So here the places are much more spread out. It will search for places only that have a certain minimum price. And you see that this affects the prominence and the proximity of these results as well. So they're much more spread out. And you're going to see that a lot of these places are actually located around waterfront locations, which leads me to understand what I always suspected, which is that you're not just always paying for the food, you're also paying for the views. And another way how you can introduce bias to your search is by having proximity bias. So you can be very specific and say, I want to search for a cafe near Circular Quay in Sydney. Circular Quay is a ferry terminal that I've highlighted here with a green arrow. So in this case, you will see that the search results cluster around Circular Quay. What's quite interesting here is that there's also a couple of search results which are a bit further down and a bit further away from Circular Quay. And you may ask, well, why is that? Are there not any other cafes which are closer to Circular Quay? And the answer to that is that, well, prominence also plays an important role. So these places that are a bit further away, they may have a higher prominence than the cafes which are directly there. So this kind of result is Google's way of telling you that it said, look, I found you a couple of places which are really close to where you're looking, but there's a couple of other places that are really popular, and maybe it's worth the walk to go there. So this was a brief overview of the whole set of functionalities and the kind of use cases that you can cover using the Places API. And the Places API is available on a number of platforms. We have a mobile native library for Android and for iOS. You can use it as a web service, and you can use it also as a JavaScript library. And going forward, we would like to now focus a little bit more on the mobile native APIs, because they have a number of really interesting characteristics and features. And that is what Ravi will tell you much more about.
Thank you, Florian, and good morning, everyone. I'm Ravi, the engineering lead for the Android Places API, and as Florian mentioned, I'm here to talk about mobile native APIs on Android and on iOS. And I want to explain the advantages of these APIs, and not just give you a list of advantages. I'll go through the technology behind these advantages and illustrate with examples why these advantages exist for native APIs. In my view, there are three of them. One is that mobile APIs are easy to use. The second one is that they're battery friendly. And the third one is that they give more accurate results. So let me go through each of them with an example, starting with the first one, ease of use. Let's say you have an app which wants to get the address of a place. That's one of the most basic things that you could do with a place, right? Get its address. You could use the web service for that. You would get the Places API will return you data, but it returns a big XML or JSON response from which you will have to extract the address yourself. On the other hand, if you were to use a native API, say on Android, you would get a place object back. And this place object is very structured. If you want to extract the address, you have a get address method. You want to get the phone number, there's a get phone number method. So this is much more convenient than getting an XML response or JSON response and parsing that. But it's not just about avoiding parsing. On mobile, we offer these two widgets which make it extremely easy for a user to experience the power of the Places API. On the left, you see the Place Picker widget, which shows the user's current place and can you allow the user to select either that place or any other place on a map. On the right, you see the autocomplete widget, which allows the user to start typing in a string, say, in this case, shore, and that would autocomplete it to the place that the user was looking for, presumably Shoreline Amphitheater, as the string keeps getting typed. So these widgets are easy to use for a user, but it's not just about the end user benefit. It's also extremely easy for a developer to integrate them into an app. What you see here is a snippet of code for launching the Place Picker from an Android app. It's literally just 3 lines of code, and you get this beautiful user experience, which allows the user to pan a map, select places, shows the current place, all of that, just for 3 lines of code. So that means that as a developer, you don't have to worry about these things, how the user experience and stuff. We take care of that for you, and you can just focus on your use cases. And it's not only about Android. We have the same widgets on iOS as well, and they're equally easy to use on iOS. And if you want to try this out yourselves, you can always go to the code labs, check it out. You'll be able to do it yourselves in no time. OK. So the fact that we have structured data and you have these widgets make the native APIs very attractive from a developer perspective. And with that, I want to move to the second advantage, which is that we have engineered these native APIs to be very, very, very battery friendly. And I want to again explain with examples why they're battery friendly. So let's go back to the same example of getting data, say the address, from your app. If you use the web service, by definition, it would actually contact the web. And it has to do that on a mobile device. It has to do that over some radio. It could be Wi-Fi. It could be cellular. It could be something else, right? It contacts it over some radio. Now, network calls tend to be some of the most power-hungry operations that you can do on a mobile device. For instance, a network call that you make over a 3G radio costs 1/3 of a milliamp hour. Many of you may be familiar with what a milliamp hour is. Some of you may not. So a milliamp hour means that you're drawing a current of 1 milliamp for the duration of 1 hour. And I use this unit because this is what batteries are measured in as well. A typical battery, for instance, would be something like 1,600 milliamp hours. There are batteries which are larger. There are batteries which are smaller. But this is fairly common value. Right? Now, that 1/3 milliamp hour and the 16 milliamp hour, let's put that in perspective. Let's say you had an app which was only making network calls, not doing anything else, just making network calls. If that app were making one network call every minute, it would drain 1/3 of that battery in a day, right? Even though it was not doing anything else. So you can see why this is a power-hungry operation. OK, great. So how do we do things differently from the web service on native APIs? And we make use of the fact that people visit the same set of places over and over and over again. That picture here is actually a very good illustration of my life. I go to work, I go home. I go to work, I go home. If I want to spice things up, sometimes I work from home. But, right? Now, I hope your life is not as boring as mine for your sake. But it's still true that, if you imagine it, right, most people end up visiting the same set of places frequently, and only occasionally do they visit new places. And we can make use of this fact that people are creatures of habit, that they're repetitive in their patterns. And we cache data about those places on device. And when we cache this on device, let's say your app calls, hey, give me the address for this place. We don't have to make a network call, because that's already there on device. Maybe some other app requested the same place because the user was there before. And the fact that we can get this data out of the device means that we don't have to make those expensive network calls. And that, in turn, means that the app consumes less power. And it's good for battery. And the fact that an app is good for battery also means that users are going to be happy with that particular app, because you can see which app is consuming how much power. Right? So the fact that we're using caching means that native APIs make apps more battery friendly. Cool. And that brings me to advantage number 3. And this, in my view, is actually the coolest advantage, which is that you can, in fact, get more accurate results from native APIs. How is that? Let's consider an example app of photo tagging. A lot of people, and I mean a lot of people, end up taking pictures of their food and posting it online. I have no idea why they do that, but they do it. Right? So one of the most common things that you would want to do to such a photo is attach the location or place where it was taken. Right? Now, photos have EXIF tags, where you can put in latitude and longitude. But what does an EXIF tag really give you? Right? It'll give you a pin on a map. But that doesn't carry any semantic meaning to me or to anybody. For instance, I would never say, oh, I went yesterday to 37.3861 minus 122.0834, and I had great food at that particular coordinate. Nobody says that. Well, no normal person says that, right? But OK, so it has no semantic meaning. So as an app developer, what app developers do is try to convert this to something that's better. And using reverse geocoding, this can be converted to an address. In this case, this lat long maps to 903 Castro Street. That's definitely better, but it still doesn't carry a whole lot of semantic meaning. Again, I probably don't say, oh, I had great food yesterday at 903 Castro Street. We don't say that, right? That's one problem. There's a second, potentially bigger problem that if you look at the map, you can actually identify. 903 Castro Street here is the address of a bicycle shop. And again, most people don't eat at bicycle shops. Right? Why did reverse geocoding get this wrong? Why did it not actually pick up the restaurant nearby and map it to a bicycle shop? And the answer is that location that you get on your device, the lat long that you get on your device, is inherently not perfect. That is because it relies on sensors such as GPS or Wi-Fi and other sensors like cellular readings, which by themselves are also inherently not perfect. And this is especially true if you're indoors, where GPS does not work. So what you're getting when you take latitude and longitude from your mobile device, you're not getting a single perfect point. You're getting a point plus an uncertainty circle that is around that point. And reverse geocoding, on the other hand, ignores this uncertainty circle. It just looks at the center of that circle, and it says, oh, yeah, the nearest place is 903 Castro Street. I'm going to map it to that. Right? So that's the two disadvantages of using reverse geocoding. One is that it gives you an address, and the second is it makes this assumption that the lat long is perfect and just maps it to the nearest address. OK. On the other hand, if you use the Places API's getCurrentPlace method, it will actually give you the name of a place, and more often than not, it gives you the name of the correct place. In this case, Morocco's restaurant. So, and now again, we'll go into a technology deep dive. How is getCurrentPlace able to do this when reverse geocoding was not able to do the same thing? Right? Reverse geocoding just took the lat long, got the wrong thing. And the answer here goes back to what Florian was mentioning initially. Google has this vast database of places and a lot of details about those places. And getCurrentPlace makes use of that information, while other systems don't. Right? So it actually makes use of all of this information. And like with many other great products at Google, we also harness the power of machine learning to make use of that information. Let me give you, again, an illustration of the technology behind this and how that works. One of the things that this database has is opening hours of places. Let's say it's 8 o'clock at night. Most restaurants, or at least many restaurants, including this particular restaurant, are open, whereas bicycle shops tend to be closed at 8 in the night. Now, at the time the photo was taken, let's say it's 8 o'clock, right? This machine learning system would know that it's late in the night, the restaurant is open, the bicycle shop is closed. And therefore, it can give a higher weight to the restaurant compared to the bicycle shop. So that's one indicator that it makes use of, the fact that some places are open at certain times and others are closed. And that's not the only indicator. Popularity of the place is another great indicator. By definition, popularity of places, people tend to be at more popular places than at less popular places. And this is something this machine learning system makes use of. Geometry of the place. The fact that you have outlines of buildings and you have an uncertainty circle, the uncertainty circle, you can correlate it with the building outlines and see whether you're likely to be in a building or outside of that building. And this is, you can again see that. If the uncertainty circle is tiny and you're within that, it's very, very likely the system will say, OK, you're within this place. And last but not the least, signals on device. So signals such as Wi-Fi, signals such as beacons, this system can process all of that and give different weights to different places based on the signals that it is reading. Cool. So great. It processes all of this information, opening hours, popularity, geometry, Wi-Fi signals, beacons, and gives you a list of places and the likelihood that the user is currently at that place. And you can see here that it was able to predict correctly that the top-ranked place was Morocco's restaurant. And I want to stress this again. It was able to do that even though the lat long corresponded to a different place. And it was able to do that only because it made use of additional information that the Places API has about opening hours and things like that. Right? So this is very, very powerful. Not only are you getting a semantic place, like the name of the restaurant, you're also much more likely to be accurate using getCurrentPlace compared to using reverse geocoding. And that gives your users exactly the experience they are looking for, which is, in this case, tagging the photo with the name of the restaurant, and not a lat long, not like an address. Cool. OK. So good. So I showed you how getCurrentPlace can work for this app. Now, how can it work for your app? And we have 2 recommendations that we'd like to make here in case you plan to use getCurrentPlace in your app. The first thing is to make sure that the user's location is turned on. Now, obviously, if location is off, given that this machine learning system is relying on location as an input and Wi-Fi and other signals as an input, it's not going to work. So make sure that your users do have location turned on, otherwise it wouldn't work. And not just location, high accuracy location. And this is something that can be done easily using the location settings dialog. You can prompt the user to turn it on. Right? So recommendation number 1. Number 2, if you're a developer who's working with a store owner and you want to build an app, say, that uses getCurrentPlace and wants to, say, verify it's people are at a store or something like that, make sure that the data about that store or that place is accurate. Again, this should not be a surprise. We are making use of all of this data, place data, in the machine learning system. Obviously, if the data is incorrect, the system also can likely make incorrect predictions. So make sure the data is accurate. And this, for store owners especially, is very easy to use, easy to do, using the Google My Business interface. OK, so that actually concludes my deep dive into native APIs. At this point, I want to hand it back to Florian to summarize this talk and leave you with a few key takeaways. Cool. Thank you.
Thanks, Ravi.
Thank you.
Thank you, Ravi. I hope you really enjoyed this kind of look behind the scenes of what goes into getCurrentPlace and what goes into this kind of place likelihood. To me personally, it's very fascinating how you can make a very simple question, like, where am I right now? And we answered that with a lot of stuff. We answered with a lot of data, with machine learning, and with sensor data in order to give you a really accurate result. So that's really cool. Right. So let me round up this talk. So you're going to go through a lot of different sessions today, and you're going to hear about many other APIs. I want you to take away at least 3 things from this session. Number 1 is, keep in mind that places in the world are semantic. Take advantage of the semantic nature and of all these things in your app to make your app more user-friendly, give your users more context, help them make decisions. And number 2 is, if you face these kind of questions of where am I right now, tell me more information about where am I, give me more details, give me colors, give me pictures. That's when the Places API helps you. And number 3, which is what Ravi has illustrated really beautifully, if you're building an app, really consider using the mobile native APIs, because it's going to make you as a developer happy, you save time writing codes, the battery is going to be happier, and that makes happier users, and at the end you even get more accurate results. Right, so what you should do next. You can get started coding away straight away with the Places API. We have 2 amazing code labs for iOS and for Android, which help you get started so you can write your first lines of code and try it out what it's like. If you have questions, we're going to be after this session straight out there and happy to have a chat with you. We also have a space on spaces.google.com, so if you have later a question and you just want to type, we're happy to answer that. And of course, we have our developer documentation. Great, so this is how you can understand your place in this world. I hope you have a great day at Google I/O, and thank you very much for attending this session.